in this exercise we are going to see array, using array how to implement queues. So real time, queue means in a train, when we are standing for train, the person who comes in is the rear end, who goes out from the queue is the front end. So now let us see the first part of this queue, that is the linear queue. Queue is divided into linear queue and circular queue. First let us see about linear queues. Linear queues, actually it will be in a single line, but one disadvantage is that once it gets in, to retrieve back to the front position is very difficult. For that we have to do some assumptions that we'll be studying in the next part. So there are some logics are used to check the full. The max, the full size -1. This is the rare case of NQ. That is what I said. Why we do not prefer linear queue and we prefer circular queue, because linear queue will not go back. Once it reaches the rear end, it cannot go back to front. Whereas in circular queue we use modulus operator, which will return back to the front from rear end. Next is to NQ, what are the operations we have to do? Normally if you take like similar to stack, how you remove the stack and not removing the stack. This is pushing into the stack. Like you have to, when you push it into the stack, we have to, so similar to push operation, we can add the elements into the stack. How we add the elements into the stack, like that. Here also we can add it into the array value, and then later you can increment it also. Then how to check empty? Using this operation equal to -1. Then rare case of DQ. What can we do for the DQ? Rare case, when front and rear are pointing together, that time we can follow this. Actually rare cases, again it will not come back. It's not coming back from rear end. Here the front and rear end, actually when there is only one element in the queue, that time front and rear end will be pointing together. So that is a difficult situation. So that situation, how to recover? Using this formula you can recover. Then to DQ, again how you remove or prop out from the stack, you can pop it out and store the element, and later you can increment it. So now let us see the program. In this program, it will start with the same basic program. Here why I use cases, switch cases. Actually here I need to, as I said, I need to add an element to the queue and remove the element back from the queue. I can use directly, why should I go for switch cases? Actually adding element and deleting element are two separate operations. If suppose I'm not using the switch case, first I used to try, that time what will happen, +1 if I'm doing, -1 I'm not able to do, because within one bracket you cannot do. Switch case you cannot bring the adding and removing, you cannot do. So we go for switch case idea. Then NQ, as I discussed in the previous slide, for NQ is similar to pushing into the stack. So that time normally we will your stack, if it is full, that time you will not push. That's the same case here also. The same stack formula you can use. And then else case, this is a rare case, that is your it will be full only, your stack or your queue. What will happen when it is full also, what will happen, the front and rear will be pointing at the last, that time it will create problem. So that case, to recover, it has to, the last rear has to point, the front will be at the last, it has to point back to front. So for that I can use this formula. Then later, this is a basic how we use in the stack pushing. You have to push the element in the stack, that is the element is pushed into the array. So when you push it into the array, automatically it will be transferred to the thing. Then dequeuing also, here also when dequeuing, why should I check empty? because anything you have to take from something. You have to take it means there should be something inside. If it's empty, you cannot take anything. So it cannot be performed in empty. So you have to make it sure that then you have to proceed for the operation. Why should I go for this? Again, there is a rare case. That is, at the end it will be at the end of the thing. There is only one element in the queue, means that is the rare end is pointing at the end. That time, when it is pointing like that time, it has to show empty. But what it will show, it will be showing like there is element, there is element, there is element. Even when the elements are removed, it will be showing like there is element, there is element. So in that case, we have to remove that. Then later, we have to proceed the operation. Operation can be proceeded only outside the loop. One common mistake I made means I try to use this thing inside. When you make it inside, there will be some errors will be created. Incrementation, there will be problem. These loopings are very, very important. It has to be done properly because it has to be stored. When you pop the element, you are storing it. That should be out of the loop. You should not bring it inside all these loops. That should be kept separate. This should be kept separate. Then later incrementation. And then displaying all the values. Normally for displaying, where we'll go? For the for loop. For loop, how starting, from the starting up to the end. So this concept I can bring it an example, means that is stack. So how your stack you are doing the same way. And the logics I have already explained in the previous slide. The same logics only are coming in the program also. And very important to handle is the disadvantage. That is at the end how to handle. Now let me run this program, build and run. Let me enter a choice. So in this I have given here 5 as my NQ, 6 as DQ and 7 as the display. So when I type 5, choice 5, it will ask me to enter a number. Okay, let me enter this number to be entered. Then it will ask, I have given, again let me input again another value. Okay, continuously let me input. So that I can bring the value of stack put. Again enter your choice 5. I'll just give some element. I'll try until I get put. So now my queue is put. So now if I display my elements, what like to show how these elements are there and go on. So now let me check empty. The same program I'll check empty. So 5 choice, no need 5. Okay, initially I have to input some value, then only I can empty it. 8, 8. Oh, let me go. This is 5. Then I'll give. Now let me enqueue this one. So after enqueuing at one particular stage, so let me display the value of this. I'll be getting, there is no element means it will show 0. So if we are adding some element, means it will show that. You can just display it and also what element you have added, you can see it. So with this particular exercise can be winded up. Before winding up, I'll just compare the concepts. These elements in the queue, all these things, the switch case is created, So how this adding, switching cases, it's all logic. Using the logics of full. When it is full, it cannot win. Then it is doing. Then in DQ also, when it is empty, it cannot proceed. Then only it will. Circular. So in this content, circular queues also, as I said, the disadvantage of linear queue, that is not able to go back when you reach at end, and that when it is one element only is there in the queue, that time what will happen? When there is only one element in the queue, it will be showing that it is empty like. So to overcome that, I will be doing some operation. So in linear queue, what are the logics available? Here there are some logics. basic how to check full. The same what we studied. It's not like that. Here extra we use modulus operator. Modulus operator max. So suppose rarend is 4 plus 1 5. 5 divided by 5 is 0 means it denotes that it should go to the front. From the rarend it should go to the front. So that it will, when it is full, automatically the thing, your rarend, your front from the last, it will point to the last front. Next, rare case of NQ. That is, to overcome that, the same thing only I am bringing. Then how to NQ? To NQ, like a push operation, you are pushing inside the elements. Check it empty. How will you check it is empty? Why should I check empty? Because for DQ operation, something is there only you can empty. Then rare case of DQ again, what we have discussed in the previous linear Q operation only. Then how to DQ? Means the basic logic, how you are popping from the stack, the same thing only, you are popping from the stack like that. Here we use modulus operator. In both the cases of NQ and DQ, we go for modulus operator. The reason is the disadvantage of linear Q. You have to overcome it, means this is the only way. Because how this modulus is bringing in, modulus will bring remainder. So when your remainder is 0, that time it is understood that the pointer, whichever, it's a front or rare, it will come to the 0. That is the starting point of your Q. That is the front end it will be pointing. So that is my logic and it will be going on. So now let us see the program. So now let me explain the same program. So this program is similar to that previous one, only we are using here modulus operator. In that here modulus operator we'll use for maximum value. It will be easy. So and here also we'll use modulus operator max, so that the 0 remainder it shows it point to the front end. Here also modulus max. So if it is front means it will point to the rear. So opposite. To bring opposite I can use this modulus operator. These are the disadvantages faced by everyone, because front and rear is pointing together. The last only one element is there. That time front and rear are pointing together. It is empty, but the computer is not understanding it is empty. So that case, when it through the front it is reaching, automatically I will make it as it is empty. It will reach the rear end. That is the logic. Only these two logics plus this one. Actually totally 3 logics are new to this concept rather than linear Q idea. So let me build and run this program. Building and running this program is very simple. Again I am entering 5 as my option. To enter the number it is asking me, let me give it. Here same logic only I am trying. Choice. I will check it whether it is going up to yes. My program will go until it reaches the full. See, you can see it is reaching full. Now at this time let me display all the values, then you will understand more better. So it will display all the values so rightly it will display. So you can understand how your program works. So let me try the same thing for a different value. Build and run. Okay, I can check whether it is empty. Okay, initially I am entering the element. Let me make it this. Then again I will go for entering the element. Then that is NQing. Let me give different element. Then we'll know. Then I'll DQ it. Again it will show empty. Now let me display the value. What is that? It will be 0. The third case I will display a normal displaying of this element. How it is supposed. Enter your choice. Invalid choice if it is the wrong means. Then 6. From on 6 I'll give 5 again. I'll enter another element. Now let me list out all them. So what is that? Even the invalid choice will be left out, and what is that printed exactly. And you can continue your program if you like. So in this the same switch case, because the switch cases I will be able to shift to the different case things, because then only adding elements in one particular cases, removing element in another cases, and displaying in another case. Like that I'll be able to use only using switch cases. Then I'll be using the same modulus operator to here front end will rar end will be going to front, because when it is full it has to go front. Like that I'll be using, actually here I'm rar end, I'm bringing it to front. Here I'm using it to check it to full also I can make it, because here we are using the same, not here. Here I use front is front plus 1, because it is incrementation operator, you can check it. Front will be made to rar and rar will be made to full front. Opposite thing we can make it here, because modulus operator remainder value will bring that logic, so that logic I can apply here. Because of that only all these things are going on. Let us have a quick recap of the content we have studied. Quick recap. So in this first, so far we have seen how arrays are used to collect elements and send out elements, so that enqueuing and dequeuing operations are done, like the stack. Then linear queue, the same way. In a single line I am doing all these operations. In circular queue another type will be studying. The main thing why we go for the circular queue is, linear queue, when your elements are filled up at the end, sometimes it create problem. That is that it will be showing like it is not full. So front and rar will be pointing. Front will be at last, so it will be showing it's empty. That time it should go back, go front. Front from the last it should go front. Like that I can make. And rar also, when there is only one element in the your thing queue, that time also front and rar will be pointing. That also is a problem. It will be showing like it is empty. But there is just one element also it will show itself. So that also you can make it right using this circular queues using the modulus operator. So apart from that, linear queues, the basic operator to check why we have to check full means similar to stack. Something is there. Now there's not a condition. Actually, everything is full means you cannot push anything. You cannot put anything inside. That's why we go for the operation. The formula. Then rar case is again when it is full, it is showing like front is -1. The point and show empty. That case front from the last go from front. And to enqueue, I will be pushing the element into the array collection. I will be pushing. Then I will be incrementing later. Then how to check empty means, why should I check empty? Because when nothing is there, I cannot take anything from that. How will you pop? Similar to pop, only here dequeue operation we are going to use. So that is the reason I will be pointing -1 already in the initializing global declaration. I will be initializing as -1. Then rar case of dequeue, again it will be pointing to the, as I said at the end it will be pointing. So that thing you have to overcome means we will go for when it is pointing like that, I have to pointing at last. Front and rear will be pointing together, so that you have to make it right. How will you make it right? Front and rear are pointing together. That time, that is only one element in the queue, but it is showing it is empty. So you have to show that is there is some element. So for that we'll show that it is empty, -1. Then dequeuing also can be done. You can take from the array all the elements. Then circular queues, the same logic what I've discussed previous case only will come. Here only checking full, I'll be using modulus operator man. They use same wordings means it will make it opposite. If it is front is there means that time it will help me to go to the last part of it. Here front and rear, this is used to check the size. Rare case of Q, the same thing only NQ will come. Then to NQ, the same logic. Here modulus operator, as I said, when it is full, the element will be sticked in the last element. It will not come to the front. Later you cannot NQ at all. It will be like a skip. So to overcome that, we have to use this modulus operator. Is a very good one. To check empty, again the same thing what we have studied previous linear queues. Rare case DQ also same thing only. Then to DQ, I am using modulus operator. Same way. From the front, I am bringing to the rare, because it will be showing like it is something is there, that I have to make it. Nothing is there.